a little bit of fun with if statements and create this very simple game where we simulate the age-old game of how many fingers am I holding up. So it's going to look like this. We'll ask the user how many fingers am I holding up, and they simply have to guess a number between 0 and 5. So if I guess 4, for example, oh, I get it wrong. The number was 0. If I guess 2 on the next one, nope, the number was 5. You get the idea. I'll just do one more guess. Nope, wrong again. Oh well. So this is what we're creating. And as you may notice, there's one fairly crucial new bit of code that we need that we haven't covered yet, and that is random numbers. We haven't seen how we can generate a random number with JavaScript, but I'm going to set that as a bit of a challenge. So if you're feeling confident, then just have a Google and see if you can work out how you create a random number which is 0, 1, 2, 3, 4, or 5. The information is already there. And as I've said before, the art of coding is really about 80% looking stuff up on Google, so you might as well get used to it early on in the process. Don't worry though, if you can't find the information or can't quite make it work, I'll explain that at the beginning of the process as I go through making up the game. So best of luck, hope it goes well. All right, did you manage it? I'm going to start by just taking us down to our basic code structure so we can start from scratch. So let's start by looking at that random number generator that I mentioned. What we want is a random number between 0 and 5 to represent the number of fingers that the computer's imaginary hand might be holding up. So let's do a little Google. JavaScript random number 0 to 5. Something like that. Because it's such a general query, we might even be able to have something as specific as between 0 and 5. So here we go, generating random numbers in JavaScript in a specific range. That sounds perfect. Good old Stack Overflow. So how can I generate a random whole number between two specified values in JavaScript? Perfect. Let's have a look. Now that looks like a great answer, but it's using functions and returning, and we haven't seen anything like that yet. So I'm going to ignore that one and see if we can find a simpler example. No, not really. Still got functions here. Okay, now this is looking good. So this code should return a random number between 1 and 10. So let's see if we can break it up and see what's going on. I think the key command here is this math.random. Definitely seems to be generating a random number. So why not take that bit of the code, math.random, with the parentheses, because it's a function, so it's going to need those, and just see what happens when we run it. It looks like it's going to generate some sort of random number. So for now, let's just alert it and see what we get. Right, 0.48. Okay, let's run it again. 0.14. Right. Okay, I think I get the idea. I think what this is doing is generating a random number between 0 and 1. And I could verify that if I wanted by just Googling the math_random function and seeing what information I could get about it. So, if this is generating a random number between 0 and 1, and I want a random number between 0 and 5, I probably just want to take this and multiply it by 5. And we do that in JavaScript using the asterisk or Shift 8 on my keyboard, and then the number that we want to multiply by. So this will create a random number between 0 and 1 and multiply it by 5. So that will give us a bigger random number between 0 and 5. So we've got 2.5, 1.2, 4.1, 3.4. We're getting the idea. This is looking good. The only problem we have so far is that this is a very precise random number, and it's unlikely the user is going to be able to guess it. So what we want to do is get a whole number out of that. And going back to our Stack Overflow answer here, this math.floor function looks like it does exactly that. If I wanted, I could look up that function, but what I'd rather do is just try it out and see what happens. So math.floor, and let's apply that to all of this. And now run it. Oh, I've got an error of some sort. Oh, yep, that's because I need a second bracket at the end there. Okay, so now I've got 1, 0, 4, 0. This is looking good. Okay, so what it's looking like is that this floor function essentially gets rid of the decimal point. So if you've got 3.521, then that will give you 3. And again, I could check that with a quick Google if I wanted to. So this is looking very good. The only issue is, what we're never going to get out of this is the number 5. Because the biggest that we're going to get from our math random times 5 is 5. And even that is extremely unlikely that we get exactly 5. So if we want to get a random number between 0 and 5, we need to change this to times by 6. And then the random number will go between 0 and 6. And then the math floor will take it down to between 0, 1, 2, 3, 4, and 5. So that's as far as I think you need to go on the explanation of how we generate our random number. Now I'm going to give you the opportunity to create the game using code that you are familiar with. Good luck. All right, here we go then. Let's go from the start. And let's start with the HTML so that we know what our page is going to look like. So I'm going to start with a paragraph asking the user, how many fingers am I holding up? So you might want to add a bit more information there just to clarify that essentially you're guessing a random number between 0 and 5. But I'll just leave it at that. Then we're going to have on the next line an input with a type of text and an ID of guess, because this is going to be where the user guesses. And then straight after that, I'll put my button with an ID of check guess, because that's what we're going to do when the button is clicked. And then guess. Let's have it with a capital G. All right, let's have a look. Okay, yep, that looks good to me. So the user's going to tap in there, guess 4, and then click that button to see if they're right. Okay, so now we've done the content, it's time for some logic. So again, we want this logic to happen when the button is pressed. So we're going to start by setting our onClick for our button. So we've got document.getElementById by ID, as we're very used to. The ID is check guess to get the button, and then we want to set onClick to a function that we'll create in curly brackets. And as usual, I'll just check that everything's set up okay. Yeah, brilliant. All right, so let's start by generating our random number. I'm going to create a variable to contain it, and I'll call it random number. And I could create it all in one go, but then we get that sort of slightly confusing code that looks like this. And I don't really want something like that. I want something a little bit clearer. So I'm going to create it step by step, starting off by just doing math.random. So far our random number is anything between 0 and 1. So first off, I want to make it between 0 and 6. So what I do is I take random number and I set it equal to whatever it was before multiplied by 6, as we saw a few moments ago. So now we've got a random number between 0 and 6. We want to make that into a whole number between 0 and 5. And we use the math floor function for that. So now we take random number again and we set it equal to math.floor random number. So if it's 5.3, it will become 5. If it's 0.89, it'll become 0, etc. So now we've got our random number in a format that we want it. So now it's just a matter of checking to see whether the guess is the same as our answer. So let's find out if the guess, so that is document.get element by ID, and the ID is guess, and then we want to get the value of the input. So if that is equal to random number, then we'll alert, well done, you got it, something like that. And if it's not, then we'll alert, nope. And we'll tell the user what it was so that they feel like we're not just lying to them. The number was, and then hopefully you'll remember from a few videos ago when we concatenated our strings or put them together. And we're going to put random number on the end of that. So that will say nope, the number was, and then it will display whatever the random number was. All right, let's take a look. So it should work in its current form. So I'm going to guess 3. Surprisingly enough, I got it wrong. The number was 5. I'm going to keep guessing 3 until I get it right. Nope, the number was 2. Nope, the number was 1. Nope, the number was 4. Nope, the number was 0. Oh, we could be here for a while. So yeah, this is not the best game that anyone's ever made. Gosh, I'm unlucky. Hey, I got there in the end. Brilliant. So I hope you managed to make that more or less by yourself. There's obviously quite a few ways you could take this to make it a bit more interesting. So just to give you a few ideas if you want to experiment, at the moment we're generating a random number each time, so the user only has one guess. But what you could do is generate the random number at the beginning when the page is loaded, and then allow the user to have several guesses just for that random number. And then it would be a challenge of how many guesses it would take to get there. You could even use the greater or less than signs. So that is signs that look like that, greater than, and that less than, to tell the user whether they're too high or too low. That would be a great challenge and make the game quite a bit more interesting as well. But I will leave those challenges to you, and we will move on in the next video to a second fundamental way of altering the flow or the logic of your code is a loop. And we're going to look at 2 different types of loop, and the first one is the for loop. So loops are a little bit tricky to explain until you see them in action, and then they really are quite straightforward. Essentially, they allow you to run certain lines of code again and again, doing usually something slightly different each time. So let's see how we set up a for loop. We use the command for to start off our loop, and then we need to add some information for our for loop. And first off, we create a counter variable which counts each time we go through the loop. So we usually create that with var, and the standard letter that we use for counting is I. That's been used since the very early days of computing. It's likely because I is short for index. So it's the index which counts how many times we've gone through the loop. And then we set that value to something initially, and usually we start with 0. So we've created our counter variable I, and we've set it equal to 0 so far. Then we use a semicolon, interestingly not to end the command, but just to end that little bit of it and give the next instruction, which is how many times we're going to do the loop. So if we want to do the loop 5 times, for example, we would keep on going as long as I is less than 5. So the first time I is going to be 0, then the next time it's going to be 1, next time it's going to be 2, next time it's going to be 3, then 4. So that will be our 5 times. So that's the instruction to keep going as long as I is less than 5. The final instruction, the third and final instruction, is what to do to I each time. And the usual thing is to add 1 to I. So it becomes 0, 1, 2, 3 each time you've gone through the loop. There are two ways to do that. The most kind of obvious way is to do that. So each time you go through the loop, take I and set it to the old value of I plus 1. So that essentially increments I each time. That's a bit wordy though, and we use it a lot in loops. So there's a shortcut way of doing it, which is I++, which is quite a neat way of saying just add 1 to I. And that works in pretty much every programming language. So it's a pretty cool thing to learn. All right, so now we've set up our loop. It starts off with our counter variable equal to 0. It adds 1 to our counter variable each time, and it keeps going as long as our counter variable is less than 5. So then we need to give the instructions of what we want to happen each time the loop takes place. And just like with functions, we do this in curly brackets. So the same as if statements as well. And for now, all we'll do is alert the value of I. So this should give us 0, and then 1, and then 2, and then 3, and then 4, and then stop. With any luck. Let's take a look. So yep, 0, 1, 2, 3, 4, stop. Brilliant. So that's the long and the short of it, really. Let's just play around with it a little bit to get you thinking. If we change that to a 3 and that to a 7, can you tell me what this is going to alert? Go for it. Did you get it right? Let's see. So it starts at 3, then 4, then 5, then 6, then stop, because it keeps going as long as it's less than 7. All right, here's a challenge for you. Can you change it so that it, instead of going up by 1 each time, it goes down by 1 each time, and we get 5, 4, 3, 2, 1. Go for it. Hope you managed that. So we're going to start with I is equal to 5. We want to keep going as long as I is greater than 0, because we want 5, 4, 3, 2, 1, and then stop. And instead of I++, hopefully you guessed this, to decrease by 1 each time, we use I minus minus. So this should give us 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. Brilliant. All right, feel free to play around with that much more and see if you can find different ways of doing things. But I'm actually going to combine for loops and arrays because they are really a match made in heaven. Going back to our example when we introduced arrays of tweets, if we want to display all the tweets and we don't know how many there are, what we're going to need to do is loop through the array. So we start with the first tweet, display that, move on to the second tweet, display that, etc., etc. And that's actually really easy to do with loops. So let's set up our array of tweets. I can't remember what my inane tweets were last time. Something like this. I love cornflakes, and we'll have one more. Let's say it's night night and a smiley face. Lovely. I quite like this guy. All right. So I'm going to set this as a challenge then. Can you display or alert each of the values in this tweets array using the loop? Go for it. Okay, hope you managed it. All we need to do is set I back to 0 at the beginning. And we want to keep going. So remember, this is the 0th tweet. This is tweet number 1. And this is tweet number 2. So we want to keep going as long as I is less than 3. Because we want I to be 0, 1, 2, and then stop. And of course, we want I to go up by 1 each time. So I'll change that back to I++. And then we're going to alert tweets. But which item do we want? We want the ith item. So this will be tweets 0 the first time round, tweets 1 the second time round, and tweets 2 the third time round. So let's have a look and see if that works. Hi everyone comes up first, excellent. I love cornflakes, and then night night. Brilliant. I hope you managed something like that. Now, extra bonus points for you if you realized that in our Twitter program, as we've mentioned, we don't necessarily know how many tweets there are going to be. So what we can do is change this 3 here to, as we saw in the arrays video, we can use tweets.length to give us the number of tweets in the array. So tweets.length at the moment is 1, 2, 3. But the great advantage of the code as it is now is that I could add a 4th tweet. Let's say sweet dreams. Oh, and I forgot my semicolon there as well. And then without updating this code at all, it will now display, with any luck, all 4 tweets. So 1, 2, 3, 4. There we go. So that's how we loop through an array with a for loop. And that is a really useful thing to be able to do with pretty much any web app or website that we're working on. Little final challenge for you then. Can you change this code so that instead of alerting all of the tweets, it displays each of them on a separate line? Go for it. All right, I hope you managed that. Not that easy, but not too tricky either. Let's create a div for our tweets, which I'll give an ID of tweet div. And then what I'm going to do is create a variable called tweet string, which is going to hold the HTML for my tweets. And then at the very end, I'll update the tweet div ID to have the content of tweet string. So each time we go through the loop, I'm going to take tweet string and I'm going to set it equal to whatever it was before. So tweet string. And then I'm just going to remember that I've got the equals incorrectly placed there. So that's var tweet string. So we're taking tweet string and we're setting it equal to whatever it was before plus, and we're going to need a paragraph tag and then the tweet item itself. So tweets I, and then we'll close the paragraph tag. So this will add a paragraph containing the new tweet to tweet string. And finally, when we're done, I'm going to take my tweet div and add the HTML to it. So document.getElementById. The ID is tweet div. And we want to set the inner HTML of that to be equal to tweet string. All right, let's take a look. Oh, okay. Now this is good. I've got everything that I wanted and it's on separate lines, but I've got this interesting undefined up here. So have a quick moment to think about why we might have this undefined at the top there. Did you get it? It's because even though we've created the variable tweet string, we haven't set it equal to anything. So at the moment, when we define it, it's equal to undefined because it's not been set equal to anything. So the first time we do this, we're taking tweet string and we're setting it equal to tweet string, which doesn't have any value. So that's why we've got this weird undefined at the very beginning there, and then we're adding other stuff to it. So the lesson from that is you should always give your variables a value, even if it's just an empty string. So this tells JavaScript that we're going to start off with an empty string and then we're going to add some information to it later on. So if we now run that again, we should find that the undefined disappears. Great. I hope you managed to do most of that by yourself, and I hope you're beginning to see the power that we can get by combining for loops and arrays for displaying large amounts of data in our websites. Good stuff. Now, as I mentioned, there are two types of loops, and we've looked at for loops here, but actually my favorite type of loop is a while loop, and we'll see how that differs and why we might use each different type in the next video. Our for loops can be used to cycle through arrays. We'll see how we can do exactly the same thing with a while loop. And then we'll see a different example that shows the situation that you might prefer using a while loop rather than a for loop. So I'm going to take what we've got here and just turn it into a while loop first off from a for loop. And that should hopefully make it pretty clear how while loops work. So remember, with a for loop, we start off with stating that I is initially 0, and then we keep going as long as I is less than the number of tweets or the number of items in this array, and we increase I by 1 every time. So to do that with a while loop, we would set I to be 0 outside the loop this time, and then we get rid of our for instructions and replace that with a while, and then all we state in the definition of our loop is the condition for the while loop to continue. So while I is less than, and again, tweets dot length. So this will now keep going as long as I is less than tweets.length. What we don't have yet is an instruction to increase I by 1 every time. And that is now a complete while loop, which will do exactly the same thing as the for loop that we had before. So let's just check. Yep, there we go. We get exactly the same output, but you can see the logic is a little bit different. We're defining our counter variable first, then we're saying keep going as long as our counter variable is less than this, and then each time the loop goes through, we're manually adding 1 to I. So it's the same thing, but structured slightly differently. I actually prefer while loops generally because they're a bit more flexible, but in most cases when you're using a for loop, you could use a while loop. It's up to you. So when might a while loop be a good idea? Well, to demonstrate that, I'm going to go back to our How Many Fingers app, but I'm going to turn it around. So instead of us guessing how many fingers the computer is holding up, the computer has to guess how many fingers we're holding up. And essentially, I'm going to set it up so we state how many fingers we're holding up, and then the computer keeps taking random guesses until it gets it right, and then it tells you how many guesses it took. So I'm going to set this as an optional challenge. So it's quite a tricky one, but we're not going to do any Googling. There's no new information here. It's just using while loops in a more advanced way. So I'll give you a moment to pause the video and give it a shot if you're feeling confident. All right, I hope that went well. Don't worry if it didn't, it was a tricky one, as I said. So I'm going to start by saying, how many fingers are you, that is the user of the website, holding up? And then we'll have an input with a type of text and an ID of, let's call it my number. And then a button that says guess. And we'll give that an ID of guess. That's it. So the idea is that we'll say 3 and then the computer will have to guess. So as usual, we want the action to commence when the guess button is pressed. So we'll set that up, document.getElementById, guess, and then we want to add an onClick to that, which is our usual function, and then curly brackets. And then I'm not going to do a check immediately this time because I'm pretty confident about that, but I'll set up a variable, my number, which is going to equal whatever the user has entered. So that's going to be document.getElementById, and the ID is my number, and we want the value of that, as we've seen before. And I'm just going to alert my number. Just because I don't want to do too much before we know that everything's set up okay. Brilliant. That's looking good. So now we're going to get the computer to choose a random number between 0 and 5. So we've done this before. So we'll call this guess, and that's initially going to be math.random. Then we multiply it by 6. And then we use math floor to make it a whole number between 0 and 5. All right, then we want to do a check to see if the computer got it right. So if guess is equal to my number, then the computer got it right. So for now, I'm just going to put a little comment in there saying computer is correct, else computer is wrong. So what we want to happen is we want this to go on and on and on until we get to here. The computer is correct. And then we want to tell the user how many goes it took. So what I'm going to do is set up a variable called gotIt. And this is going to be a new type of variable that we haven't seen before, which is called a Boolean. And a Boolean variable is either true or false. So initially, gotIt is false because the computer hasn't got it yet. And then when it has got it, we'll set gotIt to true. So this is the clever bit. We're going to keep going as long as gotIt is false. And we're actually going to keep doing all of this until gotIt is no longer false. So let's indent that so that we can see this is all part of the while loop. So remember, the computer gets it at this point if guess is equal to my number. So at this point, we will set gotIt is equal to true. And we also want to alert gotIt. And now if they're wrong, we want to just add 1 to the number of guesses so that we know how many guesses the computer has had. So let's set that number of guesses. So we'll start off at 1 because it's going to take the computer at least 1 guess. And then if the computer gets it wrong, we'll add 1 to the number of guesses. So take a moment just to see the logic of this. As long as gotIt is false, we're going to go round and round. Oh, in fact, there's a slight problem there because I closed my curly bracket. Yep, that's better. So as long as gotIt is false, we're going to go round and round, keep guessing until gotIt becomes true, and then we won't do it again. So you can hopefully see one big advantage of this is that while loops can have varying lengths. Now that is true for for loops as well, but while loops are kind of set up for that more naturally. So this is simply going to keep going until the computer gets it right. So let's just justify that we've got it right by telling the user what it was. So it was a, and then we could use either guess or my number here. They're both the same, doesn't really matter. I'll use guess. And then we need to say, it took me, and then let's just expand this so we can see it clearly. Number of guesses. So hopefully that makes sense. We're going to say gotIt, it was a, and then whatever the number was, it took me number of guesses. So let's have a look. I've done quite a lot there without checking, so fingers crossed it worked. So let's try 3 and guess. Got it. It was a 3. It took me 9 guesses. Sounds about right. 2. It took me 2 guesses. Excellent. So it looks like our system is working. Fantastic. All right, so that's how our while loop here works and how potentially it can go on until something happens. We don't necessarily have to state how many times it's going to happen in advance. It does give me the opportunity for a quick warning though. And when you use while loops like this, we need to be careful that our while loop is not going to potentially go on forever. Now, we're guessing continual random numbers here, but there's a very small possibility we could go on for ages and ages before the computer gets it right, but that's pretty unlikely and I'd be willing to let that go. But as we've got a free input here, the user could enter a 6, for example, and if we press guess, now something very bad is going to happen, and essentially what we've done is we've crashed the browser because the computer's never going to get it, because the computer only guesses 0, 1, 2, 3, 4 or 5, so it's not going to guess 6. So we'd have to have a check in place. I'm just going to restart that page, hopefully it'll let me. But we should definitely have a check to make sure that the user has entered 0, 1, 2, 3, 4 or 5. There we go, it's even become unresponsive. Yikes. We definitely want to avoid that. So a better option here would be a drop down. So my final challenge for you for this video is to change the input to a drop down or a select, which only allows the user to enter 0, 1, 2, 3, 4 or 5. Go for it. All right, I hope you remembered how to do it. I've actually realized that I've forgotten to close the paragraph as well, so let's do that. So instead of an input, we're going to have a select. The ID will remain the same, but then we'll have our options. So we've got 0, 1, 2, 3, 4, 5. Let's put those in. There we go, end the select, and then have our button. And I think we slightly need to actually put the paragraph down there. There we go. So let's take a look. This now is cleaner, and there should be no way that this should crash. One final way that you could be absolutely certain would be to have a check at some point to see if the number of guesses was bigger than 100 or something like that. And if that was the case, then something's probably gone wrong. That'd be a good way to make absolutely sure this thing wasn't going to crash. All right, so that's a good use of while loops. You'll be pleased to hear that you've nearly made it to the end of the JavaScript section. We've got one more video on functions coming up next, and then we're going to be making our big JavaScript project, which is a reaction tester. Right, we're nearly there at the end of this section, but there's one more important JavaScript concept I want to get across before we go and make our reaction tester. And that is functions. So we've already kind of looked at functions already. So we've created a function which is just a chunk of code that happens at a certain time. And we've made this code to happen when that button is clicked. But we can also create our own functions that do whatever we want. So I'm going to get rid of the text that's there for the moment. And this, but we will come back to this because we're going to be remaking this with functions at the end of this video. But for now, let's just see how we define a very basic function. So to define a function, we use the keyword function, and then we call the function whatever we want. So I'm going to make a very basic function that just sends an alert. So I'm going to call it alert me. And then we use parentheses as part of our function definition. This one, I'm not going to send any information to it. I'm just going to call it. So we've just got empty parentheses as we've seen before. And all this function is going to do is alert, hi there, Rob. And that's it. So at the moment, that won't do anything because all I've done is defined the function. I haven't actually done this request yet. So if I wanted to do it, all I would do is use the command alert me to run the function alert me. So that will now alert, hi there, Rob. So you might ask, why would we bother doing this? It's a little bit of a complicated way of just doing that. Well, the main thing is what you'll probably find when you're writing bigger, more complicated websites is that there are certain things that you want to do again and again. And what is generally a really bad idea is writing code and then copying and pasting that code into different portions of your JavaScript. Much better is to collect that code together into a function and then just call that function whenever you want to do that thing. So if you are making a game, for example, you might have a function that moves the main character. And then when a key is pressed, then it calls that function and moves them in a certain direction. Or you might have a function getTweets, which gets the latest tweets for a particular user, and then the program can display them wherever you want them. So they're essentially a way of keeping your code better organized, more easily updatable, and easier to read. As a general rule, if you find yourself writing the same command twice, it's probably better to put it in a function. So functions can obviously do a lot more than just alert things. And as we've seen, they can receive values as well. So let's see how we receive those values. Let's say, for example, I'm writing a website which requires me to average numbers a lot. So take two numbers and find the average of them. So if I wanted to find the average of x and y, let's say I've got an x which is 5 and a y which is 10. Obviously I could do x plus y and then put that in brackets and divide it by 2. That would give me the average of those two. But if I was doing that again and again and again, I'd probably want to store that code somewhere else so I didn't have it in lots of different places in my app. So how could we do that with a function? Well, let's change this function to be called average. And this function is now going to need two numbers because it can't tell you the average of the numbers unless you tell the function what the numbers are. So within our function, let's call these numbers a and b. And that means that whenever we call this function average now, we're going to need to pass two numbers to it. So then our function is going to take the two numbers, add them together, and divide them by 2, just like we said here. And what we're going to want is the result to be given back once the function is complete. And we do that using the keyword return. And then we put whatever value we want to return in brackets, like that. So what this will now do is allow us to call the function average with two numbers, and then it will return the value of those two numbers added together and divided by 2. So let's see it in action. Let's alert the average of x and y. Let's have a look. The answer is 7.5. So this is calling the function average with the two numbers x and y, and then the code will jump over here to average, and then it will do the calculation, add them together and divide by 2, and then it will return that here. So essentially it replaces this with the number that it finds when it adds them together and divides them by 2. So again, a fairly trivial example, but you can imagine some code where you're averaging a lot. It's a lot simpler to have your average function outside and then just look at this and you'll say, oh, what I'm doing there is finding the average of the two of them. So that's how we use functions to receive and return values of things. Let's jump back using Command Z to our number guessing game and see how we can redefine this in terms of functions. Now this code is not particularly complicated. We can follow it through and just about see what's going on, but it might make more sense to extract the guessing part of it as a function. So let's see how that might look. So at the beginning of my code, I'm going to define function and I'll call it do a guess. And the only information the function needs is the correct answer. So we'll call that correct answer. And that's what we'll refer to it as in the function. So the bit that we want to extract then is this bit here. So I'm just going to copy all of that and I'll make some changes while we're in. So we're going to create our guess variable and we're going to multiply it by 6 and use floor to make it a whole number. And what we're going to do is check to see if guess is equal to not my number this time, but correct answer, because that's what we're calling it within this function. And what we're going to do is, if we've got it right, then we'll return true, which is, remember, a Boolean. And if we've got it wrong, we'll return false. So what we're essentially doing is siloing a certain chunk of code or piece of logic into its own section of our code. Doesn't change a great deal, and in this case it does make it a lot more efficient, but hopefully you can see that it makes a bit more sense to have this separate. So now I no longer need this chunk of code because the guess is all happening inside the function up here. So instead of checking whether guess is equal to my number, I'm going to check whether do a guess is equal to true, not false. And remember, I need to send the correct answer to do a guess, and the correct answer is my number here. So the logic is still the same, but the structure of the code is now a bit different, and the do a guess section of the code is taken out of the main body. So whether you think that's better than it was before is a matter of opinion, but definitely when your code gets more complicated, you'll find that taking chunks out into functions just makes it so much easier to manage. One more quick change before we run it is this variable guess is now only defined inside this function. And this is something called scope, which we'll look at in much greater detail as we go on in the course. But essentially, if a variable is defined inside a function, it will only be available inside that function. So we can't use the variable guess down here, but that's not a problem because we have the correct answer in another variable, my number. So let's just use my number instead. All right, let's just have a look and make sure that things work. Yep, 2 guesses, looks good. 5, 8 guesses, looks like it's doing the right thing. So it's the same code, just restructured in the form of a function. So congratulations, you've made it to the end of the main part of the JavaScript section of the course, but we still have our exciting reaction tester where we're going to put all of this together coming up next. End of the JavaScript section of this course. You've covered a huge amount. You've gone from pretty much zero knowledge of JavaScript to understanding how to make your JavaScript interact with your HTML, how to make your pages behave as you want them, and then how to create complex code structures using variables, arrays, loops, and if statements. In this video, we're going to put all of that together to make a great fun reaction tester. And this is how it's going to work. So we've got nice instructions at the top there, and all it's going to do is measure how long it takes for you to click on the box after it appears. So once I click there, that took me quite a long time. That was quite a bit quicker. And now we're keeping the speed pretty high. So you can see we've got a lot of randomness here. It's randomly positioned, it's randomly sized, it's randomly colored, and it's randomly a square or a circle. So there's a lot of randomness built in there. And there are a couple of new things that we haven't seen. So we haven't used timers before. We're using timers both to measure the length of time and to have a bit of a random delay before the next square or circle appears. So those two things are new, and we haven't used random colors before either. But all three of those are pretty accessible with a quick Google. So I definitely recommend you have a good go at making this one yourself. As always though, if you have any problems, you can just watch me do it and see if you would have done it a different way. So I'll give you a minute now to pause the video and give it a shot. Best of luck. So I'm going to start off by keeping things fairly simple, and I'm just going to have a simple red square, which we'll then click on to make disappear. So much like our disappearing circles program from a few videos ago. So this should be pretty straightforward. I'm going to call it shape because I know that it's going to be a circle later on as well. And then in the head, we'll have a bit of style with a type of text / CSS. And then we'll select our shape ID and we'll go for a width of 200 pixels and a height of 200 pixels and a background color of red. Okay, lovely. There we go. Next then is the challenge to make it so that when we click on it, it disappears. Shouldn't be too bad. So document.getElementById, as we're used to. The ID is shape. And we want to add an onClick and set it equal to a function. And all we want that function to do is to make the shape disappear. And we do that using, again, document.getElementById, shape. And hopefully you'll remember from an earlier video that we do style.display and we set that equal to none. Okay, let's take a look. That didn't work, I suspect, because we need the none to be in quotes. Hey, there we go. So well done if you didn't make that mistake. All right, now the main new thing, as I mentioned here, is the idea of a timer, which we haven't introduced, but let's see if we can have a Google and figure something out. So I'll go for something like JavaScript timer, JavaScript timing events. That looks promising, and it's good old W3 schools as well. So we want to work out how long it takes before the user has tapped on the square. Now, setTimeout executes a function after waiting a specified number of milliseconds. We will need that actually later on when we want to make the square appear after a random period of time, but that's not what we need at the moment. At the moment, we need a timer to measure how long it takes. And I don't think this page is going to give me that. Okay, maybe I need to be a bit more detailed in my Googling. I'm going to leave that live though, because we'll need it later on. Let's try JavaScript measure time, something like that. Measuring time taken for a function to execute. Okay, we don't quite want to measure how long it takes a function, but we do want to measure how much time has passed, and this is now looking very promising. So it looks like we can use the date.getTime function to get the current time, and then we can use it again later on to work out the difference. Fantastic. Okay, so let's try that out in our code. So I'll make it so that the time is first measured when the page is loaded. And then when we click, we want to get a new time. So we'll call this end. And then, according to this code, we just subtract the two, and then that should give us the time that's passed in milliseconds. So we'll call this time taken, and that is end minus start. And then let's just do an alert for now. Alert time taken. All right. Let's have a look. And actually we want to make it disappear straight away, so we'll do that before we do any alerting or anything else. Okay, let's see. So if we click on there, 1976, that sounds about right. So that's just under 2 seconds. If I do it quicker, we get a smaller number. Brilliant. So first off, bear in mind that this is in milliseconds. So let's divide it by 1,000 to get the time in seconds. And let's also add a paragraph which is going to contain the time. We don't want it alerting every time. And the way I'll do that is with a span. I'll call it time taken. There we go. And it doesn't need to have any content initially. We're just going to fill it in here. So instead of alerting time taken, we're going to find the time taken by its ID. So get element by ID and time taken. So that will get the span. And then we want to set the inner HTML of that span to be time taken. And then we want to have an S to make it clear that this is seconds we're talking about. All right, let's take a look. So now, instead of alerting, it should display my time there. Brilliant. Okay, so now we've got our basic functionality in place. Our next challenge is to get our shape to appear after a certain number of seconds. So as it happens, the first Google link that I clicked on showed us how to do that. So this is the set timeout method. I always prefer looking at the examples rather than the kind of definition. I think they make it a bit clearer. And here, so we can use set timeout to run my function after 3 seconds or 3,000 milliseconds. Fantastic. That's exactly what we want to do. And we know all about functions because we learned about them in the previous video. So let's set up our function first off. Don't know why I copied that really, I didn't need to. We could have typed that out ourselves, but we've got it now. So my function is a little bit vague. We want it to make shape appear. So we do this using document.getElementById, and once again it's shape, and we set the display again, but this time not to none, but to a different option which will make it appear. Now, we haven't done that before, so we should just check. I think something like this. Okay, that one looks promising. Hide and reveal text and graphics. We already know how to hide it. We just need to make it display. And there we go. So style display is none, we've already used. So style display is block. That's what we need to make it display. So that essentially brings it back into the flow of the page again by giving it a display property of block. Okay, so that will make the shape appear. We also want to start the timer at that point. So what I'm going to do is I'll define my start up there, and then I'll update it when the shape appears. So this will run as soon as the page runs, and because the start variable is defined out here and then the function is defined within that, we'll be able to use the start variable inside that function. So again, this is about scope. Anything that's defined inside the function can't be used outside the function, but things that are defined outside the function can be used inside the function. I hope that makes sense. And then we just need a command to make the shape appear after, let's say, 1 second for the moment. And it looks like the command that we need for that is set timeout, and then the name of the function, and then the number of milliseconds. So let's do that here. So I don't want to run my function, I want to run make shape appear. And let's do it after 1,000 milliseconds. All right, so hopefully that makes sense. If not, just go back and watch the last few seconds again, because we did quite a lot of new stuff there. One thing I will need to change is I'll need to actually hide the square before we start, otherwise making it appear won't make any difference. Alright, let's take a look. So fingers crossed, the shape will now appear after 1 second. There we go. And it will then count the counter from when it appears. So this is the first time that the reaction timer actually works. Let's see how quick I can get there. 0.2 seconds, not bad. See if you can do better than that. Alright, so I'm happy with how things are going at the moment. Next, I'm going to make it so the amount of time that it takes for the square to appear is not fixed. So we've got 1,000 here, so let's make it a random number instead. So I think we can pop that straight in here. We know how to create a random number. So this will create a random number between 0 and 1. We need to decide the maximum length of time that we want for this to appear. So we don't want it to be 10 minutes, otherwise the user is going to get very bored. So let's say 2 seconds for now. So this will give a random number between 0 and 2000. So up to 2 seconds. Let's just check that that works. Yep, looks promising. I think that was different to before. We'll have to wait and see. Alright, so we're moving along pretty quickly here. We've got our random time. The main issue, of course, is that it only happens once. And then the game is over, which isn't great. But that's actually really easy to fix because of the way that we've set up this function. So now all we need to do is when the user clicks on the shape is to run the function make shape appear again. And then this will make the shape appear. One problem though is that that's going to do it immediately. So as soon as I click on it, it's going to reappear immediately. So there's two solutions to that. Either I could bring in the set timeout method here as well, or I could bring the set timeout method into the function. And hopefully, if you've been listening carefully to what I've been saying about functions, you'll want to do the second one, because we avoid having the same code twice in our script if we possibly can. So it makes more sense, I think, to set up another function, whoops, with a small f, which I'll call, say, appear after delay. And then that's where we'll put our instruction to make the shape appear. And then instead of calling that directly, we'll have appear after delay there, and also appear after delay inside our click code as well. So hopefully that makes more sense. If you can imagine, an immediate benefit of that is that if we didn't do it that way, we'd have to have the set timeout method twice. So if we wanted to change the maximum from 2 seconds to 5 seconds, for example, then we'd have to change that in 2 places, which isn't a nice thing to have to do. So I think it makes more sense to keep it as it is. All right then, let's have a look. So we should get a bit of a delay. Oh no, a bit too much of a delay there, because I've forgotten the parentheses. Always a parentheses when you've got a function that you're using. Let's try that again. Okay. Fantastic. That's working really well. Brilliant. So now we're going to make the game a little trickier by moving the square around. And as always, there's a few ways that you could do this, but I'm going to do it with positioning. So you'll remember, hopefully, that if we set our position to relative, then we can do things like setting the top to 100 pixels, which will shift it down 100 pixels. And we can also set the left to, say, 200 pixels, which will shift it right, or give it a left margin of 200 pixels. So what we want to do is to introduce a element of randomness with the top and left. So we'll do that in the make shape appear. And you should be able to guess really how we do that with JavaScript. We get the shape in the usual way, and then we're affecting its style here. And we're affecting the top. And we're going to set the top just before we introduce any randomness. Let's just set the top to 50 pixels. And then we'll just check. It should be down 50 pixels. There we go. So we have moved it down a certain number of pixels using JavaScript. But we want that to be a random number. So let's get rid of our 50 and let's bring in a variable. I'll call it top. And this is going to be the number of pixels. And we want that to be a random number. So math random. And if that's 50 pixels, let's say up to a maximum of 400 pixels. And then we just use top plus and then px on the end to be clear that it's pixels that we want to move it. So now it should be in a random position vertically each time. There we go. Excellent. So now it's just the same thing with left. So let's have a left, which is math.random times, let's go for 400 again. And then we want to do exactly the same thing. Get the shape element by its ID, and this time we'll set the style dot left, and that's going to be left. And then pixels on the end to give our units. So now it should be randomly positioned both vertically and horizontally. Brilliant. We're really getting there. Okay. While we're really into our randomness, I want to give it a random size as well. So let's give it a random width of, let's go up to 400 pixels. That's going to potentially let it be really small, but let's see how that works out. And then once again, get the element and set its width to width plus px. And I'll set the height to the same thing, because I don't think we want sort of strange shaped boxes. I want to keep them all as squares. So let's see what effect that has. Yeah, I quite like that. I think that makes it interesting. Okay, 400 may be a little bit large. Let's go for 300. All right, so really it's now just a matter of refining the game a little bit. And one thing I definitely want is a random color generator. So this is again something we haven't done before. So let's see what we can get from a Google. Random color generator in JavaScript. That looks pretty good. Let's have a look. Okay, fantastic. So this looks like it does what we want. Let's just run through it and make sure that we understand what's going on. Okay. Right, so what this is doing is taking the letters and numbers that make up our HTML color codes and splitting them into an array. So this dot split splits a string into an array. So what we've got here is letters being an array of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and A, B, C, D, E, F. Then we've got our color string, which starts off with a hash, as HTML colors always do. And then we've got a for loop, which starts with I is equal to 0, goes on as long as I is less than 6, and increments I by 1 each time. And then, well, we haven't seen this before. This is a way of appending to a string. So color plus equals means we take color as it is and we add to it letters. So that's this array up here. And this is now familiar to us as well. So we're getting a random number up to 16 and we're using mathfloor to effectively get a random integer or whole number between 0 and 15. So essentially this is creating a random HTML color code. Brilliant. So we learned a couple of new tricks there, as well as got some code that will be useful for us. So let's add this function definition to our code. It's doing some nice automatic indenting for us there. Lovely. So now we've got our code in there. Let's change our background color. So document.get element by ID shape and then style, and where is it, background color. Let's just see it all on one line. So we're going to want get random color, empty pair of parentheses because it doesn't need any variables passed to it, and that's it. So that should give us a random color each time as well. There we go. Bit of green, bit of purple, bit of grey, bit of blue, pink. Fantastic. A little bit of green. Okay, this is looking great. So there's actually only one more feature I want to add on the shape itself, and that is I want it occasionally to appear as a circle. So let's say we want it to be a circle 50% of the time. We can do that with an if statement. And we'll take, once again, good old math.random. And so if that's bigger than 0.5, then we'll make it a circle. We could have less than there as well. Doesn't make any difference, but this will happen on average half the time. So to make it a circle, hopefully you remember, we get the element by its ID as before, and style, and what we want to do is set the border radius to be 50%. There we go. So that means it should be a circle. There we go. 50% of the time. 2 circles, 3 circles, 4 circles, and it's vanished. I think that's a problem with our code. I think it's there somewhere, but it's so small I can't see it. So I think we're going to need a minimum size. It does appear to be a circle every time, which is unlikely. So let's have a look and see if something's gone wrong. Ah, yes. Can you see what the issue is? It's quite a good one. What it is because it was a circle the first time, we set the border radius to 50%, and then the border radius was set to 50% full stop. So even if it wasn't greater than 0.5 the second time, it was still a circle. So we need to add an instruction to say if that's not the case, then set the border radius back to 0. Well done if you spotted that. So as before, border radius 0. Okay, let's have a look. So now we've got a square and a circle and something very small. Oh, there it is. And a square and something very small again. Okay, we definitely want to have a minimum size here. So let's change the width to be a random number from 0 to 200, and then we'll add 100 to that. And that effectively gives us a random number between 100 and 300. So it shouldn't get too small. There we go. Brilliant. So we're nearly done. All I'm going to do is wrap it up a little bit, give it a nice font and a bit of a title at the top so it looks like more of a finished article. So that's pretty trivial in the scheme of things. But still, makes all the difference. So we'll call it reaction time up there. And then we'll have an H1 which says test your reactions. And a little bit of instruction. So let's say click on the boxes and circles as quickly as you can. And I'm going to use a neat sans serif font, and we'll do that for everything. So I'll use body, and then we'll set the font family to, I'll keep it simple and just choose sans serif. See how that looks? Okay, nice. I'd like a little bit more emphasis of your time down here. So let's make that bold. And we'll do that with a class of bold. So font weight is bold. And there we go. So let's have a look. That's working great. Fantastic. Hope you enjoyed that one. See if you can get a better time than me. And as always, there's a lot of ways you could extend this. So you might want to save the user's quickest time, for example. So it displays that constantly, and then that gives them a challenge to beat it. You might want to show their average time, or you might want to change the way the box displays. Completely up to you. But I hope you enjoyed that, and as always, I hope you managed to do a fair bit of it yourself, or if not, that you realized after we completed it that, yeah, maybe I could have done more of that. Congratulations once again for getting pretty much to the end of this chapter. We've just got one small video left, and that's going to show you, just like with CSS, how we can store our JavaScript in a separate file using external JavaScript. So if you can tear yourself away from our addictive reaction timer for just a few moments, I'd like to show you how we can separate our JavaScript from our HTML in just the same way that we did with styles. So let's first separate our styles to remind ourselves how we did that at the end of the previous section. We're going to create a new file, and I'm going to call this style.css in the same folder as the javascript.html file. And then I'm just going to open up the javascript.html again to get the styles and cut, so Command X or Control X, and then here in brackets I can actually bring out a menu on the left there so that I can see several different files at once. If you're in a different text editor, then you can just switch back and forth between the different files using window. So once I've taken those styles, I can put them into style.css. Good to get our indenting right. And then back in the HTML file, hopefully you'll remember that we create a link with a rel or relation of style sheet, a type of text/CSS, and an href or the hyperlink reference of style.css. And that's it. So if we just check that and run it, it should look exactly the same. Fantastic. Finally then, we're going to do the same thing with the JavaScript. So ignoring the script tags for the moment, just copy all of the JavaScript out, and I'm going to cut that. So Command X or Control X on Windows, and then I'm going to create a new file and I'm going to paste all of my JavaScript right in there. Okay, and then I'm going to save that as script.js. So the .js is of course the JavaScript extension, just like .css, but for JavaScript. And then it's just a matter of getting rid of those script tags completely and replacing them with our JavaScript. Now, in most cases, you can put JavaScript at the head or at the end of an HTML document. I generally recommend doing it at the end, partly because all of your HTML elements will be in place by then, but also because it gives the chance for the browser to load the page before the JavaScript kicks in, which usually allows the user to start reading the instructions, or at least looking at something before the JavaScript has to finish. But there are a lot of other considerations as to where you put your JavaScript, which are beyond we need to discuss right now. So I'm just going to pop it at the end, and we do this using script as before. And as before, we give it a type of text/JavaScript. And this time, instead of an href, we give it an src, short for source, just like an image. And then we select our file, so script.js. And for script tags, we need to manually close them like that, unlike link tags. So let's have a look. That should work in exactly the same way as before, and it does indeed. So hopefully you can see that, especially if you're working with a big website, we've now got everything really nice and neat, and I've got all my JavaScript together in one file, I've got my styles together in another file, and I've got my HTML in a third file. So it's nice and neat, efficient for browsers if they're downloading a number of different pages on your site, and pretty straightforward to maintain as well. So once again, congratulations on making it to the end of the JavaScript section of the Complete Web Developer course. Go and grab a cup of tea and a biscuit, but don't take too long because we've got some jQuery to look at, and you'll be amazed at what we can achieve in just a few lines of jQuery. See you in the next section.